Today we'll be solving LeetCode 2009 minimum size Subarray Sum. We'll learn these key concepts. In the sliding window, we need to maintain a dynamic contiguous section of the array instead of checking every possible subarray. So this sliding window technique we used in the previous video also. Here this sliding window will not be a fixed size. Then second is expand and shrink. This is similar to the concept we learned in the previous video. When we move right to expand the window and move left to shrink it once the target is achieved, target is reached. Then this approach works because all elements are positive. So and minimum window tracking. Every time the sum is at least target, we calculate right one is left plus one and update the minimum length. We need to track the minimum length size. So let us look at the problem now. So we are given an array of positive integer nums and a positive integer target. And we need to return the minimum length of the sub-array whose sum is greater than or equal to target. In this example, nums equals 2, 3, 2, 3, 1, 2, 4, 3 and target is 7. So we can see that the subarray 4, 3 has a minimal length and the sum of the 4 and 3 is 7. So it is achieving target and the length is only 2. There is no other array less than 2. So this is our answer. Similarly, in this 1 is our answer because target is 4 and if I take this subarray, then I am achieving a target. So output is the minimum length size, that is 1. In this the output is 0 because even if I take the whole array, then also I can't achieve the target. So constraints are important. All the numbers are positive. So that is a very important point. Now let us think of the brute force. So brute force will be to check all the subarray sums and get the minimum length. So it's we need to check all the arrays starting with one particular index, all the subarrays. So I can write loop through loop through the subarray, loop through the array for every index I get all the subarrays. If sum of subarray greater than equal to target, I will update the min. So I will initialize the min value. Min length equals infinity, or I can say y to keep infinity as infinity because it can be possible that no, even if I take the full array, then also it can't reach the minimum length. So if sum of subarray is greater than equal to target, then I update min length. Min length equals min of min length, comma length of subarray. And finally I return the min length. but time will be of O n square because we are getting all the subarrays. Now we know that all the numbers are positive. So I think we can do something better because we need the smallest contiguous subarray whose sum is at least target. And because every number in nums is positive, expanding the window always increasing the sum and shrinking the window always decreases the sum. This makes sliding window technique ideal. So we maintain a window between two pointers because all numbers are positive. We can maintain a sliding window like this. So when we move right, then we increase the sum. We maintain the sum of this window, and when we move towards the right, we add right to the sum, and when we move to the left, move left by one value, then we subtract the left from the sum. So let's write its pseudocode. So optimal approach is sliding window technique. Our we initialize left equal to 0, current sum equals 0, minimum length equal to infinity. And for right from 0 to n minus 1. We add nums right to current sum. And while current sum is greater than equal to target, we update minimum length, subtract nums left from current sum, and move left forward. Left equals left plus 1. And if minimum length was never updated, so return 0. That is minimum length is infinity only. Return 0. Else we return the minimum length. So that's the pseudocode. Now let us write the Python code for this. We initialize left current sum and minimum length. Then we loop uh, through the length nums, through the range of we loop through the through all the indices of our array nums. Now we keep on running current sum plus equals nums right. There will come a time when current sum is greater than equal to target, and then we run a while loop. We calculate window length and update min length. Then we move left by 1 unit. So for that we do current sum minus equals nums left and left plus equals 1. Then finally we return this way the while loop will continue till the current sum is greater than equal to target. Then for loop once while it exits while loop, it will inside the while loop our left is getting updated, and inside the for loop outside while loop our right is getting updated. So once left right is done, all the right values have exhausted, then we will return the minimum length, that is 0 if it is equal to infinity, else it is minimum length. Now let us dry run to understand this code and check our logic. So let's take target equal to 7 and nums equal to 2, 3, 1, 2, 4, 3. So let us now track right at right equals 0. At right equals 0, our current window will become 2, because left equal to 0 and right equal to 0, and our current window is left and right, so that is equals 0, 0. So that is nothing but 2 only, right? And sum equals the current sum equals to minimum length will become 1, that is min of infinity comma uh, window size is 1, len of current window. Now current sum is less than target, so actually it will not update the minimum length. This thing at right equal to 0, the current sum is equal to, and current sum is less than target. Current sum is less than target, so it will make right equals 1 at right equals 1. So ignore this. This will not take place now. It updates the minimum length only when it goes inside the while loop. Now current window will become 2, 3. Current sum equals 5, and again current sum is less than target. Now at right equals 2, current window becomes 2, 3, 1. Current sum equals 6, and again current sum is less than target. So at right equals 3, current window become 2, 3, 1, 2. So current sum becomes equal to 8. Now current sum is greater than equal target. So my while loop will start executing. What happens if in while loop? My window length is calculated. So window length equals 4. That is right minus left plus 1. So my right is equal to 3. 3 minus 0 plus 1. So initially our left was equal to 0. Current sum equal to 0. Min length equals infinity. So that is equal to 4. Now our minimum length will become equals min of infinity and 4. That is equal to 4. And our current sum will become 8 minus nums left. Nums left is num 0 is 2. So 2, that is equal to 6. And left will become 1. Now current sum is less than target. So my right will increase at right equals 4. Now my current window becomes 3, 1, 2, 4. So current sum is greater than target, greater than equal to target. So window length equals 4 again. That is 4 minus 1 plus 1 equals 4. Our right is 4 and our left was 1. Now minimum length equals remains 4. Then my current sum reduces. It was 10, so 10 minus 3 is 7. 10 minus 3 equals 7. And left will become equals 2. Now current sum is still greater than equal to target. So window length will be 3 now. Minimum length will become equal to 3. And now current sum will be updated. It will become 7 minus the first element or nums left. Left was 2 and nums 2 was 1. Because 7 minus 1 equals 6. Left equals 3. Now current sum is less than target. So our right will move forward. So at right equals 5. Now our current window will get updated. So in this way you can complete the dry run. But I think we are going in the right direction. So why the inner while loop? A single if condition could only shrink the window once. However, after removing one element, the window might still have a sum greater than or equal to the target. We should keep shrinking it to find the smallest parent window ending at the current right. This is what ensures that we find the minimum length. So let us try to run this code. In case you find it difficult to understand, please mention it in comments. So test cases passes. Let's quickly see the time complexity. So time equals simply order of on, because we are scanning the array just once, and space equals o1 because we are not maintaining any extra array. See, also there is a while loop inside the for loop. Every element enters the window once and leaves the window once. Therefore, the total number of pointer movements is at most 2n. That's why it is of on. Let us submit the code now and see if all the test cases passes or not. Okay, so all the test cases have passed. Now finally let us discuss common mistakes. So first mistake is using if instead of while when shrinking. Second mistake is calculating the window length as right minus left. So it should be right minus left plus 1. Forgetting to return 0 when no valid subarray exists. Then applying this exact sliding logic when negative numbers are allowed. Yes. So remember that when negative numbers are allowed, then removing an element does not reduce the sum. It can increase the sum also. And similarly, adding an element does not increase the sum. It can reduce the sum also. So when negative numbers are allowed, we can't use this logic. And final mistake is shrinking before recording the valid window length. We need to record every valid window length so as to get the correct minimum. Now there is one follow-up. If we are able to solve this in O and log n time, so yes, it is possible to solve. We can solve this using prefix sum and binary search. Since all values are positive, the prefix sum array is strictly increasing. For every starting position, we binary search for the first prefix sum that is at least current prefix sum plus target. So let's write the solution for that. We'll initialize where n equals the length of nums array prefix sums. We initialize prefix sums as 0 of length n plus 1. Then we populate prefix sum by going through the array. For I in range n, we write prefix sum I plus 1 equals prefix sum I plus nums n. Then we write initialize minimum length equals infinity, maximum possible number. Then we run a loop for start in range n. This n is our length of the nums array. Required sum equals prefix sum start plus target, and n equals, we use this function uh, bisect left, and we import this from here. If n is less than or equal to n, we update our minimum length. And finally, we return after coming out of the loop. So our start runs from 0 to n minus 1. And this function bisect left. It bisects the required prefix sum array that we have created here to find the required sum. So basically, it is nothing but it simply does a search for every starting position. I am searching in the prefix sum, the required sum. So bisect left is I am not sure. Let me check it. What bisect left actually does. Okay, so it is written the bisect left function in Python builds bisect model uses binary search to find the index, where an element should be inserted into a sorted list to maintain its sorted order. So simply it does binary search to find an index, so that my second element, the parameter, when that is inserted, then sorted order is maintained. So in this way I get the end, and now if I get the position of required sum in the prefix sum. So we are going by the logic that first we for every uh, starting position we are finding the ending position. So the time complexity will be of order n log n, because this binary search takes log n time, and we are running this for every start value. Start value takes n different values, so total time will be n log n, and we are not maintaining any separate array, so space complexity will remain as order 1. So thus our follow-up. Let us try to run this code once. There is an error. Okay. So all the test cases passes, but it does not beats. Its runtime is very high. It only beats only 5% because it takes more time than the previous solution. Okay, so that's it for this problem.